postulates are over line segments. The first thing we're going to talk about is finding segment length. Recall that a coordinate is a value that shows an exact position. And the first postulate that we're going to talk about is called the ruler postulate. This postulate is the first postulate that has a name. So when we're talking about when we start doing proofs, you could just put the ruler postulate in your reasoning. What does the ruler postulate states? It states that the points on a line can be put into a one-to-one correspondence with the real numbers. So I have a ruler over here as a picture to show you that on this ruler, this right here has a length of 1. This right here has a length of 2. Okay, so from the beginning to this point right here, it would have a length of 2. The points on a line can be put in a one-to-one correspondence with the real numbers. So first I want to talk about, I have this line right here with 2 points on it, x and y. If I were to describe segment xy, I would write it as xy with a bar over it. But if I'm talking about the length of segment xy, I would just write xy next to each other, capital letters. So this refers to, with a bar over it, that refers to the segment. But if I don't have a bar over it, that we're talking about the length of it. Congruent segments are segments that have the same length. So over here, I have segment MN and segment OP, and then I have a tick mark on each of them. 1 tick mark. That tells me that those 2 segments are congruent. If they're congruent, they have the same length. If this had 2 tick marks and this had 2 tick marks, they would be congruent. If one had 2 tick marks and the other one had, if one of them had 2 tick marks and the other one had 1 tick mark, they would not be congruent. Okay? But they each have the same number of tick marks, therefore they are congruent. So right here, let me zoom in right here. I have segment MN is congruent to segment OP. So that's how that right there would be read. Segment, let's write that down. Segment MN is congruent to segment OP. Okay, but if I have this right here where I just have MN, there's no bar over it, and there's no bar over the OP, and I have an equal sign, well, now we're talking about the length. So this statement right here says the length of segment MN is equal to the length of segment OP. So let's write that down. The length of MN is equal to the length of OP, or segment OP, whatever you want to say. So this one right here, this is very important. When we're talking about segments, when they have a bar over it, you will use a congruent sign. Segment MN is congruent to segment OP. When there's no bar over the MN or the OP, we're talking about length, so you have to say that they are equal. Equal or not equal. Let's move on to segment addition. The next postulate that we're going to talk about today, and I'm going to move up. Segment addition. The segment addition postulate states that if B is between A and C, then AB plus BC is equal to AC. Okay, so that's all that postulate states. Moving on, the midpoint of a segment. What is midpoint? The point that, or midpoint is the point that divides or bisects the segment into 2 congruent segments. And I would say congruent because we're talking about the segments, we're not talking about the length. So I have segment AC right here. If I were to draw a midpoint right here, let's call it M. If that's my midpoint, that divides that segment in half, stating that segment AM would be congruent to segment MC. So let's write this down so when you refer to these notes later, you know what you're talking about. Point M bisects segment AC. right? That's what we have basically done. So what does that mean? This means that segment AM is congruent to segment MC. Therefore, the length of AM is equal to the length of MC. Remember, this means therefore. Okay, so that's what everything that we can state with like little symbols, right? So segment AM is congruent to segment MC, therefore the length of AM is equal to the length of MC. Okay, and that is all because point M bisects segment AC. So let's get started on some examples. We have several examples today. The first, I have this number line over here with some points on it, and we're going to find the segment length. We're going to find the length of AB and the length of CA and the length of DB. And I know I'm finding the length because I don't have a bar over those two capital letters. So how are we going to do this? We're going to take the absolute value of the difference of the coordinates. So you could go, okay, there's a segment AB is 1, 2, 3, right? That's the length of that. But we're going to do it a little advanced. We're going to do it the same way on every single one of these. So the absolute value of the difference of the coordinates. Absolute value, I'm going to do my absolute value bar. My coordinate is -5 for A and -2 for B. So -5 minus -2. -5 minus -2, it's the same thing as -5 plus +2, which is -3. The absolute value of -3 is 3 because absolute value is always positive. Let's write that down. Absolute value is always positive. Okay, moving on. So the length of CA. Well, A is at -5, so I'm going to take the absolute value of -5 minus, and then point C is located at 2.8. So -5 minus 2.8. -5 minus 2.8 is -7.8. And the absolute value of -7.8 is positive 7.8. And I'm going to box my answers so that you can see. Those are the answers. Now, the length of DB. Well, D is at 5, so the absolute value of 5, then minus, because we're taking the difference. And then B is at -2, so I'm going to write -2. 5 minus -2 is the same thing as 5 plus +2, which is positive 7. The absolute value of 7 is 7. Let's move on to, so that was finding segment length. All right, we're just adding and subtracting, and then absolute value, the length of something is always going to be positive. Moving on to segment addition, we're going to use the segment addition postulate to answer questions 4 through 6. So my best advice to you in geometry is if you're given a scenario in a problem without a picture, draw a picture, okay? So number 4 says F is between E and G. The length of EG is 26, and the length of EF is 13.65. Find FG. Okay, so first let's draw our picture. If F is between E and G, then we're going to have a segment where E and G are our endpoints, and F is somewhere in the middle, okay? And you don't really have to draw it to scale. We just know that point F is in the middle. And we know that the length of EG is 26. So this entire thing is 26. And we know that the length of EF is 13.6. So this right here is 13.6. Find FG. So this is what we're looking for right here. So our segment addition postulate would state that 13.6, and you know what, I'm going to change colors here, that 13.6 plus x equals 26. So let's write that down. 13.6 plus x equals 26. And how do I solve for x? I'm going to subtract 13.6 from both sides. So 26.0 minus 13.6, and let's do this. I get 4, 2, 1. I get x equals 12.4. Okay, am I done? I'm done, because x is the length of FG, which is 12.4. So the length of FG, and you can write it like this if you want, FG equals 12.4. Okay, moving on to number 5. Using the figure shown, B is between A and C, or point A and point C. Find the length of BC. Notice how I said that. Find, I can say BC, but that is the length of BC. Okay, so in this particular problem, I'm actually given a diagram or picture, so I don't need to draw one. So I like this. So using the segment addition postulate, I know that this plus this is going to equal this. So let's write that out. 2x plus 4x plus 3 equals 5x plus 8. And now we're just going to solve this algebraic equation. First thing I'm going to do is combine like terms on the left side of my equal sign. 2x plus 4x is 6x plus 3 equals 5x plus 8. I'm going to subtract 5x from both sides, so I get x plus 3 equals 8. I'm going to subtract 3 from both sides, and I get x equals 5. Am I done? I'm not done. This asks me to find the length of BC, and I found what x is. So I'm going to change colors again, just because I like to do this. If x equals 5, and the length of BC is 4x plus 3, if BC equals 4x plus 3, and x equals 5, then the length of BC is going to be 4 times 5 plus 3. So what does that mean? The length of BC is 4 times 5 is 20, plus 3 is 23. There's my answer. So you need to make sure, am I done when I get the value of x? No, okay, because this told me to find the length of BC. Let's move on to problem number 6. This one we've got some mixed numbers here. So point K is between point J and point L. The length of JL is 7 3/4, and the length of KL is 2 1/4. Find JK. Okay, so let's draw our picture. So we know that we have segment JL, right? And it doesn't really matter if things are to scale. We just know that K is between points J and L on this segment. And what do we know? We know that the length of JL is 7 3/4. So the entire segment is 7 3/4. And that might be how I show that. The length of KL is 2 1/4. Find JK. Okay, we're going to call it X. And you know what? I'm going to write it fancy schmancy in a different color just because we're looking for this. Using our segment addition postulate, we know 2 1/4, this right here, plus X is going to equal 7 3/4. So 2 1/4 plus X, and I'm going to zoom in, equals 7 3/4. Okay, so I have, what am I going to do? I'm going to subtract 2 1/4 from both sides. So 7 3/4 minus 2 1/4. Okay, well this makes it really easy because I'm subtracting fractions with, they already have a like denominator. So I'm just going to subtract my numerators. 3 minus 1 is 2. Keep that denominator. 7 minus 2 is 5. 5 2/4. If I simplify it, I get 5 1/2. So x equals 5 1/2. And that is my answer, because we're looking for the length of segment JK, which we called to be x, and x equals 5 1/2. So if you wanted to write JK equals 5 1/2, that works. You could also write 5.5. That also works. All right, let's move on to the next section, midpoint of a segment. Okay, again, when you don't have a picture, draw a picture. Number 7 says line M bisects segment AB at M and divides segment AB in half. Draw a sketch of the image and name a pair of congruent segments. Okay, we know we have segment AB. All right, so let's draw segment. That is a huge line, but here we go. Segment AB, line M bisects it, so we're going to split it in half. At line, lowercase, kind of a cursive letter, lowercase script, at point M. So there's point M, and it splits the image into two congruent segments. So those are congruent. I could do this right here, right? That's fine too. As long as they have the same number of tick marks, that shows that they are congruent. So I have segment AB, line M divides it in half at point M, right? Intersecting lines intersect at a point. We learned that in yesterday's lesson. So name a pair of congruent segments. Well, segment AM, line over it. How do I write congruent? Equal sign with the squiggly on top is congruent to segment MB. Could you write segment BM? Sure. You can write that in any order, okay? Just put a bar over it. Number 8, point F bisects segment EG. The length of FG equals 3x plus 5, and the length of EF equals 5x minus 1. So here I have, let's draw a picture, segment EG. All right, boom, and I draw big segments because I just don't really know how much writing I'm going to put down. EG, F bisects those segments, so it's going to split it in half at point F, and it says the length of FG, and I'm going to change colors here. The length of FG is 3x plus 5, and the length of EF is 5x minus 1. Okay, so this is all we know, all right? And these are congruent segments, right? So I'm going to put a little tick mark there to show that they're congruent. So given this information, we drew a picture for it, okay? Draw a picture when you're given some information. A says, what is the value of x? Okay, if they're congruent, then I can set their lengths equal to each other, meaning I can say that 5x minus 1 is equal to 3x plus 5. And now we're going to solve for x. I'm going to subtract 3x from both sides, so I'm left with 2x over here. Oh, hold on. Whoop. All right, so what I'll do is I'll subtract 3x from both sides. I'll take it away over here, minus 3x, and then I'm going to add 1 to both sides, so I'm going to be adding 1 over there, okay? So I'm not going to write down every step, but when I subtract 3x, I'm left with 2x. When I add 1, I get 6. Now I'm going to divide both sides by 2, so I get x equals 3. B says find the length of FG, FE, and EG. Okay, well, FG equals 3x plus 5. And if x equals 3, then what is FG? That means the length of FG equals 3. So look, over here, look, 3x plus 5. I'm going to do 3. I'm going to plug in 3 for x. 3 times 3 is 9, plus 5 is 14. That means the length of FG is 14. The length of FG is 14. Well, the FG is congruent to EF, which means EF, or FE, is also 14, which means the entire thing, EG, is what? Well, it's going to be twice that, right? So the length of EG is going to be 28. 14 plus 4. Oh, goodness. My computer's doing crazy stuff now. It's not going to let me. All right. Equals 28. So number 9 states that M is the midpoint of LN. the length of LM equals 2x minus 3, and the length of LN equals 3x. So let's draw a picture of this. So we know if M is the midpoint of LN, then I know segment LN is going to look like this, and M is the midpoint. And I know that the length of LM equals 2x minus 3, and the length of LN, that's the entire thing, is 3x. So the length of the entire thing is 3x. Okay, so if M is the midpoint of LN, and this right here is 2x minus 3, then I know this right here will also be 2x minus 3, because midpoint tells me that those are two congruent segments, which means their lengths are equal. So I can call them the same thing, right? If that's 2x minus 3, then MN is 2x minus 3. So what is the value of x? Well, we need to set up an equation to find the value of x. How can I do that? Well, I do know, using the segment addition postulate, that 2x minus 3 plus 2x minus 3 should equal 3x. That is the same thing as 2 times 2x minus 3 equals 3x, right? Okay, so let's solve this equation. The first thing I need to do is get rid of the parentheses on the left side of the equal sign. How do I do that? I distribute the 2. 2 times 2x is 4x. 2 times negative 3 is negative 6. And in this case, since I only have an x term on the right, I'm going to move that 4x to the right. So I'm going to subtract 4x from both sides, and I'm left with negative 6 equals negative 1x, which is just negative x. I don't want what negative x is, I want what x is. So I'm going to divide both sides by negative 1 to get x equals 6. And that is the value of x. Moving on to the next portion, problem B says find the length of LN, the length of LM, and the length of MN. Well, first, LM. Let's do that one, right? LM is right here. The length of LM is 2x minus 3. So LM equals 2x minus 3. We know that x equals 6. That means the length of LM equals 2x minus 3. That's 2 times 6 minus 3. 2 times 6 is 12. 12 minus 3 is 9. So the length of LM equals 9. If LM is 9, I know the length of MN is also 9. The length of MN is also 9. And if both of those segments are 9, then the length of the whole thing is 18. Okay? So I'm going to say LN equals 18. And we know that if I wanted to go up here, if I know x is 6, let's see, I'll choose green. If x is 6 and ln equals 3x, well, 3 times 6 is 18. So that's just another way to get that answer. But that concludes today's notes over line segments. I hope it was helpful.